Excellent. Okay, so do we have any questions before we start today's lecture, where we continue our overview over object-oriented programming principles? I'm assuming no. Okay, so do you all remember what we did last lecture? So last lecture, we really started talking about what the motivations behind object-oriented programming is. And then what we did was we looked at the UML diagrams and how we start modeling using objects. And the models really help us identify three different categories, three different concepts that are going to motivate our objects. First of all, what is the name of the object, the class name? Second, it's going to be what are the properties of the object, and those should ultimately resolve into something that is one of the fundamental data types, something that is either expressed as a numerical, as something that is text, or something that is a book that itself as an object that will eventually get resolved into a set of values that are of a fundamental type. Because if you recall, that is motivated by data modeling. Object modeling is kind of a layer built on top of data modeling. And then we also looked at the behavior methods. Since they're kind of like our API, the set of things that we can do to an object so that it can cooperate, so that it can perform inside of our software application, inside of our environment. Okay, so with that said, we looked at some very concrete examples, things that have kind of very rigid boundaries, that have an analogy to the real world, things like a player, things like a monster, things like a UNO student. So here I want to start kind of abstracting the idea of what we model into something like an account. So today we're actually going to step through the implementation of building an account class that's designed to build instances from. And so that kind of represents an object, but that I feel like an account object is a little bit less concrete than something like a UNO student, where when you think of a UNO student, you think, oh, that's a physical thing. Account is more like a grouping of related data. That's effectively what we're going to want to do from objects. So, I mean, many software applications utilize accounts, right? Like, so almost anything that allows you to create a username and password is going to be account driven. So it's a fundamental concept to start thinking about, well, how can we create an account where you can have any number of accounts, right? So object-oriented programming principles really support the idea of an account-driven application. So here I had kind of pre-designed an account that will kind of start to implement ourselves. So let's run through what, oh, am I not sharing my screen on here? So let's get a laptop. Okay, let's get the projector on so that the in-person class can see. Okay, so here I have an account UML that's already pre-designed. So why don't we step through this really quick to make sure we all understand what this model is. Now recall, what I'm trying to do is you can have multiple accounts, right? And so each account could potentially be different depending on what the application is. What I mean by that is, if you create an account for a bank versus an account for Facebook versus an account for like Steam, those are all going to be different. Even though they're all accounts, they're all going to have different proprietary components as to how they facilitate inside of their own environment. Like, for instance, your bank account might have information related to what your balance is and other personal information that kind of identifies you towards whatever it is being managed by that account. So again, with a bank account, it'll probably be a balance. It's going to be one of the most fundamental things that you'd have access to. But let's look at other things. Like, for instance, Facebook would probably have a list of friends. Right? It doesn't make any sense for your bank account to have a list of friends necessarily, unless you create some kind of social media banking app like Venmo, and then it does make sense, right? So like a Venmo app would have properties that are similar to a social media account and properties that would be similar to a bank account. And so actually that's how a lot of like advancements with web applications works. You find things that work in the real world and you say, how can we make it something that works well inside of this cyber environment? Going back to the Steam example I gave, if you had a Steam account, that might also have a collection of friends, but probably also has a collection of games that you've purchased, or maybe as a collection of games on your wish list. Your Amazon account probably also has a wish list, probably has a collection of orders that you've had, all your historical orders, as well as it too can have something like a list of credit lines that you can use to go ahead and complete a purchase. Anyway, the idea is, regardless of the fact that we're modeling an account, all accounts in this instance could be very different depending on what your application is. So in this instance, we're going to model an account that's predominantly designed to be like a bank account, something like if we were designing an ATM machine, what would an account object in an ATM machine look like? And so for that purpose, let's take a look here. Let's look at these first. So first of all, recall that anything that has a minus sign in front is going to be labeled private inside my class. Does everyone remember why it's pretty important to have all of our data, all of our instance fields, all of our instance variables to be labeled as private? What the motivating concept of that is?
So they won't change.
To encapsulate it and hide it so that no other class has direct access to the state of our data. And the reason why, we're going to see this in another example, either in this lecture or in the next lecture, is that all of the rules that guide whether the state of our object is valid or not are going to be defined inside of this class, because this is where we're thinking most deeply on the properties of this class. This is where we're thinking most deeply on how we're modeling this class to be a member of the entire software application that we're building out, extending, using it from. And so for that purpose, we want every other client code to have to go through our methods where we put a lot of thought, a lot of logic into ensuring that any change of state in this instance only results in a valid state change. Because if you give direct access to any other object within the software environment, they could potentially just change it to whatever, and then that can create a very brittle and non-robust software environment that can be prone to failure and errors and a nightmare of maintainability. So we're going to go ahead and list these all as private. So we have a name, which we will represent as a string. We have a PIN to access your account. That's effectively your password in other forms of accounts. So every account, regardless of what the application is, usually has some kind of name or identifier and some type of password or PIN number. We also have an ID. So it's important to state that we have an ID and a name. Why is it important to have an ID, do you think, for an account? Absolutely. Yeah, so we need to be able to discriminate between one account and the other. We need to be able to identify from a variety of accounts. If we give the account an identifier, we know we can say that this account, let's say number 1, is different than this account with ID 3, even if the name is John Smith. We can't necessarily guarantee that people's names are unique. Right? There's a lot of shared names. So we can't use that as an ID for the account. You can only use that as a way of labeling the person. Absolutely. So that's very good. So we'll have an ID for an account. We'll have our password or PIN. We'll have a name. And then finally, since this is designed to model a bank account, we'll also go ahead and have a balance. So I'll model my balance as a double. And I'll state this. Is there an alternate way that we could model the balance? So here I chose a double. I chose an int for the ID. I chose a string for a PIN, and we talked about that last class, and I chose a string for the name. But I kind of want to talk about the way I'm modeling the balance here. Do you think that this is the best way to model balance? Now, I selected this So I don't want to necessarily prejudice you in another way, but what would be another alternative to modeling a balance, right? Because that's one of the cool things about data modeling. You can do this in any way internally, and no one else has to know why or how it's fundamentally modeled, as long as they get the expected results from the class. So any ideas besides?
Technically use string? Is that possible?
String, so it would technically be possible, but then it would limit your ability to do any kind of arithmetic operations, because every time you go to do an arithmetic operation, you have to cast the string into a double, and that could be a very dangerous behavior. When you start talking about modeling money and actual applications that represent an actual value of money, you want to be as steadfast as possible. You want to be as sure as possible that nothing can go wrong. So yeah, a long, interesting. So longs don't necessarily represent a floating point value. So online, I got the suggestion that it could be a long value. And yeah, absolutely, it could be a long value. Now, longs are integer values. They're not doubles. So what would be your base unit with a long then? Well, what's the base unit of money? Is it dollars? Is there something that's more basic than a dollar? Can a dollar be broken? Cent. Is there? Yeah, cent is. So using a long value, you can actually model a balance off of the number of cents, as opposed to the double value, where our base unit is actually a dollar, and then the two decimal places, the two precision points after the radix point, we're illustrating as a percentage of a dollar, right? The number of cents that dollar has. What way do you think is better? Because now I want to challenge you. There's two correct ways, right? There's two valid ways we can model. One where we use double and where the base unit is effectively one, unless there's precision points, and that's our cents, which is typically how you probably see it most often at stores and whatnot on price tags. Or you can just use the most basic value of a cent and compute that as a long integer value, integer type, but a long data type. So what do you think? I'm interested to get some feedback. What do you think is the better approach?
I think the one with the most storage for numbers, because you don't know what the balance could be. It could be millions.
Yeah, so it could be millions. So in which case long makes a lot of sense. We could always, now double is a big number too. Does anyone remember what like the deficiency of a double value is? Where it can get, let me ask you this, has anyone seen the movie Office Space? Oh, wow, I'm super. Okay, well, it's worth watching, I think. Been a while. Does anyone remember what the motivating, for those who have seen it, do you remember what the motivating con was with the developers? How could they shave cents off though? Yeah, that's exactly what they were doing. They were shaving cents off of each transaction, right? But it wasn't actually cents, it was fractions of cents. And because the idea is that if you model money with a floating point number, they're only approximations. Remember, they're not actually concrete values. Floats are always an approximate, which means when you start talking about modeling dollars, and this is true in actual real applications, you never, ever, ever model money with floating point numbers. We do it as tests here, but if you were to build an actual application, you would use longs. You'd use something that is exact, something that has precision. The best precision is with integer types, non-fract, because now you can't shave the approximate difference in two different transactions like they did in Office Space. Now, of course, the flaw they did in Office Space was they computed what the amount was between all these several transactions and just deposited it in one big lump sum instead of doing it a micro transaction at a time. So they got caught because they just transferred like $1 million into their account. But if you were wondering like what motivated the background plot of that movie. It's literally based off of using not a good model to model money, which motivates why data modeling is so important and why these decisions, even though on the surface, they seem like there's not much consequence about using one data type versus the other. There can be very much great hindrances for one selection over the other. And that only comes with experience. But yeah, so I just want to point out, I am going to go ahead and model our balance as a double for this example. But if this were a production application, I would be using a long value and I would be treating all transactions on a balance as in terms of cents and not dollars. And that's why. It's because I want the exactness, especially when you deal with something like money, right? Because there's a real tangible loss if you make an error. Excellent. Okay, so then there is one interesting thing here. What are we seeing here inside the UML diagram? We didn't see that last time, right? We see here that I have something that's actually clearly labeled as static, also private, that's called count, that has an integer. What do you suppose this is supposed to model? So the count here is going to be the count of accounts that have been created, which we might be able to use to create an ID number. So the first account that we ever create will be, let's say, account number 1, and then account number 2, and then account number 3. So you can see why that's static, because we want to have one value for that and not have that be individual based, have that be instance based. So it is possible for a class to have a mix of static fields and instance fields. But when you make a decision on whether a field should be static or instance, should come down to this. Might I need multiple values for this particular thing, or should this have one singular value for every instance of the class? Should it have one value for the class itself? When we're talking about the overall number of all accounts created, that should be something that's a property of the class and not a property of an instance of a class. Does everyone kind of understand that distinction? Because that could be a very nuanced distinction. You're good with that? Okay, now let's take a look at some of the methods we have. We have a account. So these are all plus. These represent things that are going to have that are going to be public to outside client code. We have our constructor, and our constructor is going to take in 2 parameters. It's going to take in a name, and it's going to take a password or PIN number. Now, and then everything else, one role of the constructor, and I'll talk about this when we create it, is it's responsible for setting up a new instance. So sometimes these new instances require data to get passed into the constructor, and sometimes a new instance, the constructor knows what the starting value should be. So let's look at this, for instance, when we're calling our constructor here on account. When we create a new instance of account, we don't know without the client code telling us what the name should be, right? So we're going to need the name. Does that much make sense? And the same thing, whenever we create a new account, we also need to know what the PIN number is going to be, right? We can't know that ahead of time. So those 2 things, it makes sense. We need to pass that into the constructor so it can be set inside of our instance. What about ID? Is that something that the user should pass to us? The ID on the account. What do you think? You think the user should pass? Now, what's the dangerous thing if we allow the user to pass an ID? Exactly. There's no way to guarantee if we make this a parameter that the user is allowed to supply to us, there's no guarantee that 2 users won't supply us with the same ID. So when it comes to creating identifiers internally to our own system, because remember, the thing in ID models is the way for us in our application to distinguish from one account instance from another, then we should be in control of the rules for creating ID numbers. So that's going to be something that we internally decide on. And because of that, we're not going to pass that in as a parameter for the constructor. What about balance? What should every starting balance be before you do a deposit or withdrawal? 0. So we know that ahead of time as well. So a 0 for the balance will produce the logic to create an ID number, and then we'll need the name and the PIN number every time we create an account. And then the other things that we'll have is the application will probably need access to this data here from other instances. And since it's private, nothing else outside of the class will be able to either read or write from it. So a mechanism that allows other client code to at least be able to read data from this instance is to provide what are called getter methods or query methods. So a getter method simply returns the value that's stored in one of the instance fields. Since it's private, nothing has access to it, but since the public methods are accessible, we can create a get name, and all this does is return the value at the instance field name. And we can have a get ID, and all it's going to do is going to return the value that's held at the ID field. And we can create a get balance method where all it does is returns back the value that's held inside of the balance field. But notice here, I don't have a get pin inside of my my class definition here, right? I have a get name. I have a getter for almost everything except for pin. Why do you suppose I did not decide to do a get pin call on that?
Because only the user should know
What
that.
does it represent? Yeah, and is the pin supposed to be something that is openly available to other things? No, one of the purposes of a pin, just like passwords, means that it should be private to the end user. And one of the worst things you can do when you're safeguarding someone's information is to save the passwords or PIN numbers in a way that's easily accessible from within the system. So we should be cognizant when we start designing our software of what data should be openly requested from our objects and what should we put gates behind, what should we put safes behind, locks behind. And so in this instance, I still give availability to the PIN, but look at what I do instead. Instead of getting the getter, I put equals PIN, where you could pass in an attempt as a string, and then it gives you a Boolean response. So we can still interact with our account by providing a PIN, but instead of getting the PIN directly back, we're going to be able to evaluate privately and say whether it's right or wrong. And notice, like, you want to think deeply before just creating getter methods for everything. Like, these are the considerations you should have when you start designing out what methods you're going to provide, even something as simple as a getter method.
So where's the input coming from? Because under pin string, that's not the input at top. Pin string count.
So
That's just saying that.
So-
pin, it's just space.
yeah, so the top here are our fields. When we create an account, we're going to supply a PIN.
Oh, I see it. Okay.
Yeah, we're inside the constructor, and just in this simple implementation, once you created a PIN, you can't ever change it.
Sure.
So here, then, once we've created it, we can then try attempts, and it'll tell us whether we've gotten it or failed it. And then the last thing we're going to do is we'll also have a toString method that will allow us to represent our instance as text data, right? So that we can print it out to the console and see that as we play around with it, that its state is changing the way we expect it to. So toString methods are super powerful for us as developers to evaluate how our instances change over time, because presumably we can make withdrawals, we can make deposits, we want to test our code before we put it in production, right? You don't want to code an ATM machine and then never test it, because that's gonna be awful. So toString methods allows us to create simulations so that we can verify and validate that our code works the way we expect it to. Excellent. Okay. Oh, well, that's the actual implementation. So let's go and actually start building this. So. Okay, let's clear this. So we're going to create an account.java Java file. And the first thing we do, looking at our UML diagram, is we're going to see what the name we provided for this, and we're going to make a new class. So it's going to be public, so it's accessible to outside classes. We're going to call it account, and then we're going to open and close the scope. Oh, I need class too. Public class account. Perfect. Okay, so now we have a class definition. The next thing I'm going to do is I'm going to look at the data fields that I have here, and we're going to go ahead and add that at the top level. Before I do any methods, is usually convention to add all of your properties. So typically a class it's laid out in the same way we lay out our UML diagram. So the class name, the collection of properties, and then all of your methods. And so here, I'll just paste these for now. I'll comment them out. So this came directly from my UML diagram. Okay, so here, I'm going to create a private static int count. And I'll even, when we first started up, set it to 0. And so we can set class fields inside of the class definition, but the constructor should be the entity that sets up all instance fields. We'll look at that in just a moment. The rest of these are going to be non-static or instance fields. So here, let's make private string name. Here we'll do private string pin. We'll do private int ID. And here we'll do private double balance. Okay, perfect. So now I have my class and I have the properties that define what this class is modeled as. So the next thing I'm going to do is I'm going to go here to my UML diagram and I'm going to grab the list of methods that I think my class should have. Actually, I'm kind of missing some methods in here. What are some other things we should actually be able to do in here? I feel like we should be able to withdraw and deposit. Deposit, it doesn't return back withdrawal, but this should take in a double amount, which is some amount. No, the name and then what it is. Okay, perfect. And I think does this look fine? Is this relatively, clearly I missed some really fundamental things about having a bank account. Is there anything else in here that you think I should add? So I have account, I have get name, I have get ID, I have get balance, I have equals pin, I have toString, I have withdraw and deposit. Is that like for a basic ATM, is that right? Okay, I'm trusting that everyone's like kind of reading over my shoulder while I'm coding here. Giving me good feedback on building out an ATM machine. Okay, so the next thing I'm going to do here is I'm going to go ahead and I'm going to create mock implementations of all the methods. So at this point, I'm not going to focus in on really thinking about what the logic is. I'm just going to create the method definitions and do what's called method stubbing. Stubbing is a process where I declare a method and then I just leave the body of the method blank if it doesn't necessarily need to return anything. And if it does return something, if it's a reference type, I return null. If it's like an integer or double that it returns, I return 0. If it's a Boolean, I just return false. Effectively, I just return a dummy value. So the idea behind stubbing out the implementation is I make sure ahead of time that I put all the methods that I've planned for this class to support. And then I'm going to kick the can down of worrying about how to implement them, but I just want to make sure that they were there so I never forget about them. So I'm building kind of a mocked version, an empty version of what my class will look like when it's complete. So here, we're going to put public. So I'm going to start with my constructor, public account. And so here I'm going to actually use the Java notation. So the data type goes before the name. And here, the string goes before the identifier, the pen. And so I'll just leave that empty for now. And then here, we'll make this public. And so remember, constructors are very special. They're different than every other method because its return type and name is grouped together as the same thing. So it's the only method that doesn't have three distinct components. Like we give the access level of public and whether it's static or instance, but there's no return type that's super evident because the return type is actually an account instance. Everything else though, remember we have to have that return type. So public here, I see at the end that this is supposed to return a string. So I'm going to put in my return type string, and then I'm going to remove this tail end here. And so I see I haven't placed any parameters here. So I'm just going to go ahead and create a body. Now, since this has a return type here, and I have to have a return keyword. That's the other weird thing about an account, right? It doesn't have a return type because it doesn't use a return keyword either, right? Because it gets its value in unison with the new keyword. So it's also one of these rare things that doesn't have the return keyword, which is why it doesn't have a return type. Okay, so here, since this does have a return type, and since I said I'm making stubbed implementations, a return type of string that is a dummy would be null, right? Because it's a reference data type. It uses an uppercase letter. So I can just use a null reference just so that my implementation is valid. Public string get name. Okay, return null. Okay, let's go here. Let's do public. And then here we'll do int. And we'll do the same thing. We see that this here, the return type is going to be of an integer data type that's primitive. So for now, I will just return 0 all the time, just to have a stubbed out implementation. I'll look at get balance. I had a plus, so that's going to be public. I see the return type I labeled there is double. So I'm going to do public double get balance. I'm going to give it an empty body. Since it does have a return type, though, it's invalid until it does return something. So I'll just return 0.0 for now. For equals pen, I'm going to make this public so it's available outside the class. I see that the return type that I labeled inside my UML diagram is a Boolean. So I'm going to put that where the return type actually goes. Here, I see you actually have input here too. So I'm going to put the input in the format that Java expects it. So it's data type followed by the name. And then here, this is going to return a Boolean value. So I'll just put return false. Again, we're just subbing out all this implementation. So here, public string. So I'm going to get rid of what the return data type there is. And then here, I'll just return no, perfect. And then here for withdrawal, we'll do public void, because now we don't have a return type there. I think this is the first time we're actually creating a method that doesn't return data. Here, we're going to have to put the data type in front of our identifier for it to be valid Java. And then here, we don't have to do anything since the return type is void, so we'll just leave that blank in our stubbed implementation. And then finally, I'll do public void. I'll do the same thing here. And get rid of this. Okay, perfect. So at this point, I now have a stubbed out class. It has a name, it has all the properties, and it has all the methods, although the method behaviors haven't been actually implemented the way that they should be. They're dummy, they're just empty, but I should be able to at least make sure my syntax is correct, and this should be able to compile before I start adding any complexity of code. It's very important at this stage that you do compile to catch any easy to catch errors, because right now, this would be the easiest time to debug, right? Because there's almost no logic in that. Now, as we progress and we add logic step by step into each method, we wanna go ahead and compile in between each method. That allows us to catch any errors as early as possible so we know how to handle them. Because one of the worst things you can do, and I'm sure, let me ask you if you've encountered this, have you waited to compile your code until the very end and gotten something like 38 different errors, all like pointing at various classes and various methods, right? Isn't that a hassle to debug? It's much easier to code a little, compile, test a little, debug a little, then code a little bit more, and then debug a little bit more. Don't kick that can down, because you're going to be cussing, your future self is going to be cussing your past self for that. I've actually known people who have coded an entire project and it was so bug ridden, they had to throw away all their code and start from scratch again. There's a pretty common saying in the domain of software development. It's 30 hours of coding can save you 3 hours of planning. So, yeah. Okay, let's see here. So we were able to successfully compile. Now, it doesn't do anything, right? Now, let's start implementing this step by step. So I'm going to start with the account class. And typically, when we start building out our classes, we want to be able to kind of test to make sure that they're doing the thing that we anticipate them doing. So how might we verify that our logic works for our account? So our account doesn't have a main method, right? Because it's not designed to be an application. It's designed to be a member of a larger pool of classes, right? So it's a smaller part of something that's greater, and it's used by other code, right? So I can't just run this like some of our other applications because there's no main method to run. So how might I verify and validate that this might work as I'm building it out? Yeah, exactly. Build in a other class that has a main method that builds an instance of account and test it for the explicit purposes of testing it. So let's do that too. So I'm going to touch, let's call this account tester.java. Let's put this here. And let's do this. Let's do public class account tester. In fact, I have some dummy code for account tester in here. Let me jump to that as it's already stubbed out, and we'll actually see what we're going to be testing. So I don't have to type all this in real time, and you just watch me type out everything. Let's take a look at what my account tester looks like, because I should be able to actually run this. Yeah, I should actually be able to run this, it looks like. Okay, so here I have my account tester class. It's going to have a main method. Because remember, anything that's an actual application in Java has to have a main method. That's the launching point of all applications. Inside my main application, I'm going to create a local variable that's called test result, and it's going to be of a Boolean value. And then I'm going to call test new. So I have all these different smaller helper methods that I'm going to put all my test code into. So in order to test and make sure creating an account works, I'm going to create a tester method called test new. That's going to return back Boolean, true or false, whether I pass that test or not. Then I'm going to have a tester to test to see if my equals pen works. So I'm going to test that separate from being able to just create new instances. Then I'm going to create a tester to test to see if the withdraw function works and also the test method works. And after each one of these tests, now these themselves are stubbed out, right? So the default of a test is always fail until you've illustrated that you can pass it. So we'll set the initial value to false. So what I'm going to do is I'm going to call for test the ability to create new accounts, and then I'm going to print test new, and then I'm going to print the result. And the same with equals, deposit, and withdrawal. Let's actually test that out. And we can see as of now, my tester says my test new is false, my test pin is false, my test deposit is false, and my test withdrawal is false. And what my goal is going to be is, as I implement my class, I'm going to go into this helper, this test class, and I'm going to put in what I think should happen and see if I get a pass result. And if I do get a pass result, it lets me know I can move on to the next method. And I keep testing each of those methods until I'm happy, because what this is supposed to represent is this is the set of calls on account that I would expect to happen in a real application. So if my account class can pass all these tests, then that means it's robust enough to be performant in the actual deployed workspace where it's going to have to exist at. And so it allows me to create a playground to verify that it does everything that it's going to have to do when it's actually in the real life application that I'm going to write around it. Does that make sense? So this is a concept that's called unit testing, where we can test each unit of our code a little piece at a time. So instead of building our code all the way through and having to test it as it actually runs, we can actually kind of create objects and talk with them, call their methods, and make sure that each method call does what we expect it to do. And ideally, if all the methods are doing what we think they should do, then they will perform that same way in a real world application. So it's just a manageable way of testing every part of your software as well, to make sure that these crazy errors don't end up cropping up. And you'll learn much more about this in Java 2. This is a good preface for you that motivates how to actually design software objects in a very effective way. Okay, so let's go over here. Let's go into the constructor now. So in the constructor, I see that I'm getting in the name and I'm getting in the pin. So I'm going to use those values that are passed into the constructor to set my instance fields. So here I'm going to use the keyword for instance fields. So this dot name will be assigned the value, the local value for name that got passed into the parameter list. So the name on the right-hand side of this assignment is this one, whereas the name on the left-hand assignment is this one, the one on line 3. Two different variables. One is at the scope of instance, the other is at the scope of local. Here we'll do this dot pin is assigned the pin that got passed in. Okay, so those are the two that are required to be given to us to create a new instance, the name that should go to the account, the password that goes onto the account. Then let's see, we know that this dot balance should be equal to 0.00, doesn't matter, 0. I could have just put 0, but whatever. And then finally, for this ID, what I'm going to do to assign this is I will currently look at what count is. So on account, since this is a static field called count, I will use the class name account. I will then access from it the count. And despite the fact that that's private, since this method exists within the class, I can access any private fields to this class. So I will access and set count, but I'll also do a pre-increment. So what I'm going to do is I'm going to increment it so that it's different, right? So it starts at 0, And remember what the pre-increment does is it's going to take that value and make it 1. Then I'm going to take that value of 1 and I'm going to assign it into my ID. And then now the new value of count will be actually 1 for the entire class. So if I create another instance, it'll go from 1 to 2, 2 to 3, 3 to 4. Does everyone see how I can do that? How I can couple or utilize this static field and actually give it a different value in each of these instances? And we can actually test this to make sure it works. In fact, at this point, I'm almost done enough to be able to test my constructor. But before I can test my constructor, I need to actually also implement my toString method, because my toString method will allow me to evaluate the state of my object based off of its fields, right? Like it allows me to express my instance in the form of text. So the only way I can verify that I've created something that has these values is to implement the toString method, right? Does that much make sense? It's my mechanism to express this as a string. So here I will do what? String.format. I love string.format. I'm going to make a formatted string. So my formatted string is, let's see here. Let me grab the one that is in here. Oh, so this is what we'll use. So the formatted string that I'll use is going to be, we'll give the name, and then %s will be a placeholder value for this particular name. We'll give the account ID and then give the ID. We'll have the balance and then actually go ahead and then display the balance. Okay, so here, so that first thing is going to be the name. The next thing is going to be the balance. And the last thing, oh wait, nope, it's going to be account ID. So it's going to be ID, and then it's going to be balance. Okay, so the ordering is very important because the first parameter has to line up with the %s. So the %s is this name, then the %d for account ID is this ID, and the %.2f, as you might recall, is we're going to throttle the precision point on a floating point number to only be 2 precisions, since that'll represent the number of cents, and that'll be my balance. Okay, so now let's test this out. Oh, yeah, that's going to cause some issues. Okay, so now we have balance. So if I, first of all, now I'm going to compile this. So let's go ahead and compile our account. Okay, so that's all syntactically correct. Let's go into my account tester and let's start testing this out. And so just for the purposes of brevity here, the way that I might set this up would be along these lines. I'm going to now implement this set line. Let's see what we're actually doing here. So on the first line, 15 here, I'm going to create a local variable that's called tester pass that I'm going to assign false initially. Now I'm going to try to create 2 accounts because I want to verify that I can make more than one and that the state of it is different between 2 instances. And I also want to verify that the account ID increments the way I expect it will. So I'm going to create account 1 that's called Joe Joey with the PIN number 0060. Now remember, I modeled my PIN numbers as strings in case I had leading zeros. So I want to test that. Here, for my second account, I'm going to create a name Sue Susie, and I'm going to give Sue Susie a PIN number of 1234. So I'm going to invoke the constructor. Remember, the constructor is invoked with the new keyword followed by the account, right? That method that we created. And then it has to have whatever parameters we define. So a name and a PIN. And I'm going to save these into account variables. So I have an account 1 and an account 2. Then I'm going to create my expected string from my toString method. So the string that I expect from my from account 1 would be name : Joe Joey, right? The name that's given, comma, account ID : and then that should be account ID 1 because I do the pre-increment from 0 to 1, and then the balance should start at 0. And then what I should expect as my display out for account number 2 will have the name Susie. It'll have the account ID of 2 and also a balance of 00. So then what I'm going to do is I'm going to have my expected value, which is represented as a string, and I'm going to see if it's equal to the results from account 1 if I invoke the toString method on it. And then what I'm going to do is this is going to return something that's either true or false, right? So whether it's true or false, I'm going to preserve that. And then on the line after that, I'm going to take what my expected toString, that's the one with Susie, I'm going to see if that's equal to account 2.toString. And notice I'm using a compound assignment here. This is the and assign, the and assign. So what this does is it looks at what the previous value of test pass was. And so if it was true, it does true and whatever this resolves to be. Or if it was false, it does false and does whatever this is. Why is it important? Why is it important that I do use this compound assignment and just not this? What's that? Yeah, that's right. Because in order to pass this test, I can't just overwrite what the prior result was. I want to take into account every prior test result. And so an easy way for me to do that is just to do this compound assignment. So this way, if I did 5 test results and I just kind of ANDed them together, if any one of them failed, then the entire result would be a failure. Okay, so then when everything is said and done, I then take whatever the value of my tester pass is, and now I return that back to my main method that will then report true or false, which is what we did before, if you recall right here, when we stubbed out the implementation, so everything was a false. So let's save this. Let's compile my account tester, and now let's run my account tester. And now you're going to see with the one that I've implemented on my constructor for test new, it's now true. So I can move on. I know that when I produce a new instance of accounts and when I convert it into a string, what I think it should have in terms of a set of values is what it actually has. And so I don't have to spend any more time thinking about this method. I can move on to the next method. So again, this is a great guide for me to evaluate how well defined, how constructed each of my methods in my class are before I go ahead and share my class with the rest of the code base. Testing is super important. I want to get everyone in the habit of testing as early as possible. Okay, so now I'm going to clear this for now. Let's move on then into account. So let's see, the next thing we're going to do here is let's do the getters. The getters are super simple. In fact, the getters are so simple, typically we don't even test them because they're hard to mess up. Let me show you. We have get name. It returns back a string. All I have to do is replace the null with this dot name. I'm done. That is how we implement a getter. To get ID, I'm going to replace the 0 with this ID. To get balance, I'm going to return 0.0 with this dot balance. Okay, so these are done. I'm going to compile to make sure that it compiles. Oh, perfect. Perfect. That way I will actually get an error. So I'll test to make sure that I don't get any errors. And what I'll get is an error that shows me, hey, you spelled did instead of this, and I don't know what that is. It thinks it's a variable. So I will replace that with the this. And so now, perfect. All the more reason why we do that kind of compilation stuff. Exactly why. Okay. But usually for these as well, you'll get an error from compiling. There's no logical error that you have to test against. So the way that I test my getters is through a compilation step, not necessarily a build an account and evaluated step. Okay, this one though has a little bit more logic, the equals pin. So let's see how we might do this. Let's create something that's called is valid and set it to, well, we'll just create something called is valid. Do I care about that? I'll just do this.
Set it for this thing.
Well, I could probably just return. And let me make sure that this logically makes sense to everybody. I can do this dot pin dot equals attempt. Is that fine? Is that too much logic, or does everyone see how that's going to resolve into a Boolean value? If this makes more sense, I can show that I can create is valid and then return is valid. Right? That ends up being the same type of thing. Let's spell return correctly, right? Because what I'll do is this itself is a string. It has an equals method. I'll see if the attempt string equals this, which will resolve into a Boolean value, something that's either true or false, and then I'll just return that. Okay, so now that we have something that has a little bit more logic, let's test it out. I'm going to go into my test equals here, and I'm going to do some cheating, some copy pasta. So here I'm going to do something similar. I'm going to create my tester pass. I'm going to assign it false. I'm going to create two new accounts. So my account Joe Joey, my account Sue Susie. And here, what I'm going to do instead is, so I'll have my pen. So I don't need, my expected's going to be different here. It's going to be a Boolean value and a Boolean value. So let's decide what our test is. So let's test it when it's true. And let's test it when it's false. And so here, let's do account one dot equals pin, and let's do the pin as let's see, let's do 60. And so here, let's do the opposite then. Let's do false and true. So here, I'm going to do that, and then I'm going to do equal to expected 1. And then on account 2, I'll do the call that I'm actually evaluating. The important thing here is that I'm trying to evaluate the method I'm testing, which is equals method. Here, I'll do the actual 1, 2, 3, 4. And this will be expected 2. Okay, does anyone have any questions on how I'm testing this? How I'm testing something that's true, false?
My question was just about the account one, new account, Joey. So do we need to take this out of the 10 equation?
You mean these?
No.
This right here? Okay, so this is the thing. I'm creating, in each of these methods, I'm creating local variables. That means when the method is done, they don't exist anymore. So for instance, when after test new runs and I create account 1 and account 2, after I return, when I get to the end of that closing brace, account 1 and account 2 don't exist anymore. Now, the thing about testing is I always have to test these instance methods against actual instances. So one of the first things you're going to see me do, and this one I'm going to copy paste, I don't have to spend all my time having to type this out manually each time, is I have to create a couple of instances, then mutate the instance. And what I want to do is I want to check to see if the method I just worked produces the result I expect it should result.
So if we didn't have it in there, it would say false to the first step.
That's right. Well, what's going to happen is it probably won't even compile. So imagine that I remove these two. I'm going to comment them out for now. Right? So these are now commented out. It won't probably even let me compile because it's going to tell me account 1 is an unknown symbol. And so I'll prove that here. And yeah, here we have account 1 cannot find that symbol. And it's because we need to create an instance of an account so that we can test it, so that we can see, does it equal? Because that doesn't have a definition. There's no assignment to that instance field until we've actually constructed it. So here, what we're going to do is we're going to construct 2 new instances of account that's going to have its unique set of names and its unique ID and its own unique PIN number. And here I'm going to figure out what my expected values are so that I can compare. So here, account 1 dot equals PIN of 60, I should expect that to be false. So I'm going to do is the result of this, and this is something that results to be a Boolean, true, false. Then I'm going to do the double equal because this is on a primitive data type now. Does that equal this result of false? And I could have hard coded it as well. I could have just put false, but I like seeing the word expected. Again, just like you don't want to have magic numbers, you don't want to have magic Booleans, right? So now we know this is the expected value for the first test. This is the expected value for the second test, where we actually pass in what the PIN should be. And this will let me know that I get a failure with wrong pins and I get a correct thing for the right pins. Okay, so let's test this. Let's actually see if it compiles for me. So now that compiles, and now let's run that. And now notice, because I've actually implemented logic in my tester, I can run it without having to affect the main method. And I see that my first test method passed, true, and my second test method passed. So now I can move on to the next thing, which is going to be the ability to withdraw. Okay, so what is the logic for withdrawing? It's gonna do something with this balance, right? And I guess I should do the same thing with deposit. Let's do deposit first. Let's reverse these. We probably need to deposit money before we can withdraw money, right?
I have a question.
Yes.
Going back to the account tester dollar, why do the tester not expected to understand on its model?
Right here, because that's a compound assignment. So recall that compound assignments allow us to take a primitive operator, like what happens. Okay, let me leave that. Let me do a quick question for you here. Actually, let me open up JShell, new tab here. Let me launch JShell. Okay, so if I created an integer called x, right? And if I set x to 10, right? So I now, if I look at x, it has the value of 10. If I use a compound assignment, x plus equal 10, what's going to be the result of this? Have you seen this before? Something like a plus equal? So that's what's called a compound assignment. Compound assignments are the same as having an assignment where, so what's going to be the result of that? If I have x is assigned x plus 10, it's going to be 20, because what it's doing is on the right-hand side, it reads the value of x, which is currently 10, and then it does the addition of whatever the value is, and then it overwrites it. Well, an abbreviated way of expressing this logic is to use a compound assignment instead. So instead of doing x is assigned x plus 10, I can remove the x on the right-hand side, and I can create a plus equal assign, a plus is assignment. So it will take whatever the current value of x is, which is 10, and it will add to it what is then on the right-hand side of this compound assignment, which would be 10. So the result of this would also be 20, right? Okay, So does that much make sense? And so what would it be if I change that to a asterisk, to a time sign? Exactly. Okay, so let's do something else. Suppose I had a Boolean that we will then call Q, and then let's make Q equal to false, right? What would be the result of Q if I did Q is assigned Q and true? So if it's, so what's the value of Q here? So that's false. So it's false and true. What's that result to? So that would be false, right? Now, just like I could go ahead and create a compound assignment with arithmetic operators, I can create a compound assignment with logical operators. So I can, having this second Q is redundant, what I can do instead is I could put the ampersand assignment operator to make a compound logical operator. So will evaluate the current state of my Q and whatever the value is on the right-hand side of that operator. Does that make sense now? Okay, let's jump. And so that's why we're doing that here, because we want to maintain and evaluate what the previous state of our tester pass was and not just simply override it. We want to combine it with all the old tests. Does that make sense? So we want all the tests to pass in order to get a true. And if any one of them fails, then we get a false. But this allows us to test edge cases as well. We can test many different ways. And then if for any reason we get a false, we're like, okay, one of these ways didn't work the way I anticipated it to work. Okay, so let me go back over here then. How should deposit work? Let's do deposit. So we know it's going to do something to this dot balance. What are we going to do to balance with deposit? And we have an amount. So what are we going to do to balance? What's that? So add the amount. So let me ask you this. Does this seem good enough? We can test this out. Is everyone happy with this implementation? To take whatever the amount is and add to it the balance, which means to withdraw, we can do this dot balance. Oops. Theoretically, that would be reducing the balance, right? So here we can subtract from the balance the amount. Okay, so this works. Mm-hmm.
When you set the count to 0, it's not going to constantly set the amount. Reset the amount.
Well, we're never doing anything. We should never touch count at all. Count represents the count of accounts we've created.
Okay.
So where balance is going to represent the balance of what this account has available. Now, a simple way of implementing this, and this is how we're going to implement it, would be you pass in the amount you would want to withdraw, and you would remove that amount from your balance. And then for deposit, we'd go ahead and we would take and deposit some amount, and we would add that to our balance. Does anyone see any? We'll test this out. This is the point of testing. So if this is good enough, we'll test this out, but then we'll talk next class about how we might want to think about improving this more so. But we're going to start with the naive approach. So let's go over here. And for testing deposit, I'm going to do a similar thing I did here. And I'm going to have my tester pass equal to assigned to false. And then here I'm going to create a new account, perfect. And
It doesn't update the balance. Therefore, every time you run that, it's just going to be 0 plus
well,
whatever the amount is.
well, for just looking at the deposit, if we pass in an amount, we're going to take whatever the amount is, and it does. It actually adds to that balance right here, right? It's adding to it whatever this amount is. You shouldn't. You're getting exactly where we're going to have to get to from testing. Yeah, some deficiencies here already identified. For withdrawal, there's no check to guarantee that we have enough money to draw against. But that's exactly why we want to test those conditions. Yeah. And there's another interesting thing that we're allowed to do here that we might not want to be able to do. We'll do this with testing, and we'll probably cover this a lot more next class, but let me get this first test working, and then we'll continue to delve into how to identify. Very good catch on that before we even got into the testing of that. Okay, so so here, well, our expected value here will be, let's say, double values. So let's just test the ability to deposit. So let's do, and just for this first test, I'm just going to use account 1. So I'll have my expected 1, my expected 2. I start at 0, so I don't really have to test that per se. So let's say that my expected 1 is going to be 100. Okay, perfect. So let's just do this first test just to see how this works. Then we'll start testing on other interesting concepts next class. So on account 1, we're going to, actually, let's do this. Yeah, let's do account 1 dot deposit, and let's put in $100. Perfect. Okay, so after performing the method, now let's test to make sure it works the way we expect it to. So I have an expected value that's going to be different that I'm going to put as 100, and then I'm going to get account 1 dot get balance, and I'm going to see if that's equal to my expected 1. I'm just going to get rid of this tester here. We're just going to test the simplest case. Can we just go ahead and add $100? And then we're going to see if the balance is actually equal to this expected value. Okay.
What I'm saying is that after the balance is had, the 100 is going to pass the test. So when you take the second balance of deposit, it's going to work similarly and just continue to add the 100.
Well, let's test. Let's test. Actually, that's a great. So let's absolutely do that. So let's add 100, and so. And then let's deposit $100 more, and then on expected 2 now, it should be $200, right? So now to pass this test, and again, I don't want to overwrite this. I want to do that and assignment. So what I'm going to do here is I'm going to create account 1. I'm going to deposit $100 into it. I'm going to create an expected value of 100, and I'm going to see on my tester pass, is the balance 100 at this point, and I'm going to set that to tester pass, and then I'm going to add another $100. I'm going to put expected 2 as 200, and then I'm going to put, is my tester pass, does it pass if the balance is now $200? So it should be incrementally adding, right? Not just overriding, but it's actually adding to the balance. Let's test that. And we can see that it is indeed the case. That is true, that as we keep depositing money, it keeps building up in value. Now, we're going to test this for these edge cases, like was mentioned earlier, on how we could potentially break this. So I want everyone right now to look at this code between this class and next class, look at how we've implemented withdrawal, look at how we've implemented deposit, think about numbers that are technically legal numbers, but would be invalid operations to do at a bank. And think about that. And then I want to hear suggestions you have next class. And then we'll talk about how we can implement logic into these methods to prevent that from happening. Excellent. Is there any other questions that anyone has? Well, then have a great weekend. I'll see you all next Tuesday.
I got a question regarding the quiz. Did you open that second quiz?
No, I need to verify that all the questions are valid on it. So I'm going to do that. I'm going to open it up today.
Okay, and then